Okay, so we're talking about standard form here, and standard form is related to the slope-intercept form in this way. Slope-intercept form looks like this: mx plus b, and really all that's happened here is we've moved the x to the other side. So we've subtracted mx from both sides so that we rearrange it to look like this: negative mx plus y equals b. So really, that's all that that's really all that has happened is we've moved the x term to the left. So instead of seeing y equals mx plus b, you're seeing the x and y, the x and the y terms on the left, and you're seeing a whole number on the right. Well, it doesn't have to be a whole number, of course it could be a decimal, but you're seeing a number, a constant on the right. So that's all that's happened. In this form is not very useful, but it does have some things that you can do with it. One, the plot by using the intercepts. So let me show you that quickly. So let's say that we had this equation: x minus 2y equals negative 2. This is what we would do. Instead of we would have two options. You could rearrange it to look like y-intercept form and then plot it. That would be an option. Or you could just simply plot it using the intercepts. So this is how you do that. The y-intercept is, let me just get a little closer here. The y-intercept is actually the when x is 0. So what we're going to do is put in 0 for x. So when we do that, we get 0 minus 2y equals negative 2. Now that's really just, so this is 0, so we can just ignore that. It's negative 2y equals negative 2. So to solve for y, we'll just divide negative 2 on both sides. So you end up with y equals 1. So we have this new point. The new point is 0, 1. Now let's plot that. Here it is right here. That's 0, 1. That's your y-intercept. It's called the y-intercept because it's on the y-axis. Okay? And now let's do that with the x-intercept as well. What we're going to do is just work the same problem, but this time we're going to find the x-intercept. So the x-intercept, that is where y is 0. And so we'll use the same equation, but this time we're going to plug in 0 for y. So 0 goes right there. And so 2 times 0, well, that's just 0. So you have x equals negative 2. So you have this new point. The new point is negative 2 and 0. So let's plot that. That's called the x-intercept. So it'll be along the x-axis. So it's right here. That's your x-intercept. And now if you just snap a line between these 2 points, you've plotted your line and you're finished. Let me give you another example. Let's do number 11. All right. So first thing I'm going to do is find the y-intercept. That's where x is 0. So let's plug in x. 2 times 0 minus 3y equals 12. So this term just disappears. 2 times 0 is 0. So it's negative 3 equals 12. To find y, I would just divide by 3 on both sides. Negative 3, rather. And I would end up with y equals negative 4. So I have this new point. 0, negative 4. That's called the y-intercept. So let's plot that. It's right here. Let's use red. All right, so that's the y-intercept. Let's do the x-intercept. The x-intercept is when y is 0. Let's zoom in just a little bit. So this is where y is 0. So I'm going to plug 0 in for y this time. So I have 2x minus 3 times 0 equals 12. And so this term, 3 times 0, that's just 0. So I have 2x equals 12. I'll divide by 2 on both sides. These 2's will cancel, so I'm left with x equals 6. So I have this new point. The point is 6, 0. That's the x-intercept. So let's plot that. It's right here. I'll do it in blue. All right. That's the x-intercept. And if you just put a line through those 2 points, you've graphed your line. So you can see the standard form is useful for graphing if you use it to plot the intercepts, and then you can get your line that way. The alternative is to rearrange it into slope-intercept form first and then graph it.